Okay, so let's talk about exponential growth, one of the most important application of exponential functions. So what is exponential growth? So a function shows exponential growth when it has the form y equals b to the power x with b greater than 1. So this means the output increases faster and faster as x increases. So more generally, we can write y equals a multiplied by b to the power kx, where b is greater than 1, which means the base is greater than 1. So this controls the growth rate, and the coefficient a also should be greater than 1. So this is the initial value or starting amount, and here we consider the value of k should also be greater than 1, because this affects how fast the growth happen, the growth speed. So when all these conditions are met, the function is increasing and it models growth. So what kind of things we can grow this way? For example, we can use these functions to model populations, investments with compound interest, bacteria, virus spreads, and also anything that double, triple, or increases by a fixed percentage over time. So let's try to do some example to see how this model work. Okay, so in this example, we are trying to look at a real world example of exponential growth, which is about inflation. Okay, so if you want, you can pause the video for a few seconds and read the problem. So in this situation, suppose inflation is predicted at average of 4% per year from 2012 to 2025. So that means the price of an item increases by 4% every year. So let's say item costs $10,000 in 2012. So in 2012, the cost of an item is $10,000. So this is in 2012. So in the next year, which means in 2013, the same item will cost will cost 10,000 multiplied by 1.04. And in the following year, 2014, the same item will cost 10,000 multiplied by 104 multiplied by 104. So this price keeping this okay, so this price keeps growing exponentially with each year. So that is what this problem says. So let's try to answer the first part of this problem. So you're asked to write a function that gives the cost of a $10,000 item t years after 2012. So you can write the exponential growth model as C T. So this notation represents the cost of the item after t years. So here you can write this as 10,000 multiplied by 104 to the power t, because after first year the cost becomes this, the second year the cost becomes this. So after t years, so instead of 2 you have to replace that 2 by t number of years. So this gives the cost of an item t years after 2012. So here the base 1.04 reflects the annual increase by 4%, and the coefficient 10,000 is the initial cost, and the exponent t counts the number of years after 2012. Okay, so let's move to the second part. So graph the growth model found in part A for t equals 0 to t equals 13. So you can use your calculator to sketch this graph. So if you sketch this graph using your calculator, it will look like this. So initial value will be around $10,000. So it will be something like this. So use your calculator to sketch this. So x represents the t. When t is equals to 0, the cost will be equals to $10,000, which means it starts with 10,000 and then it grows exponentially. Okay, now let's move into the third part. So if an item cost 10,000 in 2012, use the model to predict its cost in 2025. Okay, so in part C, in 2025 is 13 years after 2012. So let me write that. 2025 is 13 years after 2012. So that means you have to take your model and you have to plug t equals 13. So let me write the model first. So the cost function gives you this function, that is 10,000 multiplied by 1 to the power 1.04 to the power t. So now to get the answer for the third part, you have to substitute t equals uh, 13. So 10,000 multiplied by 1, 0.04 to the power 13. So use your calculator to get this value. So this is around 16,650.75. So this value will give you the cost expected in 2025. So this is how exponential growth applies to real world scenarios like inflation.